you listening probably have either a Facebook, Twitter, Instagram, or some other kind of social media account. It's kind of hard to escape from. So we all know that moment when a news story pops up that makes you think, no way, I need to share this with my friends straight away. But how often do you actually check your facts before tagging people and sharing this supposed news? I'm definitely guilty of passing on messages before I check my facts. I'm here today with Elena Kochkina from the University of Warwick, who's working with natural language processing to try and help distinguish between these rumours and unverified information from the actual breaking news. So I find the application of AI in social media to sort of overcome problems in spreading fake news really interesting, especially as it's something that's only really been a problem in the last few years, with social media becoming so huge and everyone being on it all the time. So it'd be great to hear exactly what you're working on and just to have a bit of an overview of your current research.
So generally I'm working in the area of natural language processing, and more specifically I'm working with data from Twitter that contains conversations about rumors that are emerging around news-breaking events. So these events might be like shooting in Charlie Hebdo, unrest in Ferguson, and so on. And there are lots of rumors spread around them, and people start discussing them and also expressing their attitudes towards the truthfulness of the rumor. And using all this information, I'm trying to automatically detect the stance of users towards the truthfulness of the rumor, to detect whether user is supporting, denying, questioning, or commenting on the rumor. And as a next step, to also try to determine the veracity of the rumor, whether it's actually true or false, or maybe there's not enough information to verify it.
Okay, so is this done by the language that the users are like tweeting with, or is it done by algorithms? And
so I'm using recurrent neural network, LSTM, in order to model the conversational structure. So usual conversation has a tree-like structure, and I decompose it into linear branches. So I have a linear chain of subsequent responses, and I provide them to the model. And then using this context around each of the tweets, it's able to predict the label for each of the tweets. So it's a supervised learning.
That's okay. So that is quite amazing that there's sort of the potential to eliminate these rumours through AI. But what initially brought you into the field of AI, and what motivates you to keep working in this area?
So I decided to pursue a PhD in like machine learning, natural language processing, after I took a course in data mining that was taught by my future supervisors. I was really fascinated by the whole concept of machine learning, that machines can pick out subtle patterns in the high-dimensional data that human can't, and at the same time they really struggle to achieve human-like performance in some tasks that are seem very simple and natural to us. And when it all looks like a black box, it looks like magic when they are able to spit out the answers to the questions you ask them. And I mean, this field is very interesting because of how it's developing. So at the moment there are lots of attention to the field of natural language processing. There's a lot of application, and it moves very rapidly. There's a lot of advances that attract lots of smart people. It's very interesting to work in this field. I really like the discussion that are going on in this field about trying to make models more interpretable, because it is important to understand how the model made this or that decision, especially if you're talking about applications in medical domains. Doctors should know why the model is trying to predict this or that. We need to make sure that the model is not making right predictions for wrong reasons, and so on.
Yeah, and talking about sort of like medicine and healthcare, these progressions have already been huge and will be life-altering for many people in the near future. But which disciplines do you think need to come together to advance your work in classifying rumours and news to debunk this kind of false information that's spread online?
Yeah, I think it's a very good question, because actually when we think how journalists verify rumors, so they're doing sort of a detective work. They're using lots of tools that are available to them, like maps. They're using some image forensics to identify whether the media that's attached to the post is genuine. They're also using their human psychology to understand users' incentives for posting various claims. So I guess for machine it's quite hard to see like what was the intent of the user, understand the psychology. So journalists, they use lots of different tools from different disciplines, and we can also try to tackle it from different perspectives. So perspective I'm looking from is machine learning in the form of supervised learning task, where we train on known examples and try to predict on the unknown ones. But also you can look at the rumor spread from the perspective of networks, of social networks, who is connected to whom, which users are more gullible, more likely to spread false information. But also it can be modeled using models of disease spread. Mm-hmm. So that could be another approach. It's also important to build maybe models of users' credibility, not just judging by the text of the rumor, but also who posts the rumor is important. So image forensics field also will be relevant because it might help identify whether media content is genuine or not. For example, usage of natural language processing and image processing can be used together to, for example, identify if the genuine image is actually captioned wrongly and they're trying to say that it shows something it doesn't show.
Right, I see, okay. Yeah. So it all sounds quite complicated. So what problems or challenges are you currently facing?
Well, there is a lot of challenges. So one of the challenges is actually small annotated data. So for my work, in order to train my models, I need to have Twitter threads that are annotated for veracity. So I need to know which thread talks about the true rumor and which thread talks about the false rumor. And we cannot just make anybody label those rumors because they don't have domain knowledge. So we would need to hire professional journalists to do that for us, and that's quite expensive. So this is one of the challenges, is to gather annotated data.
Okay.
And another one, which is more like on the theoretical side, is domain adaptation. So I can make an example of domain adaptation from sentiment analysis. For example, language used in reviews of movies will be different to reviews of restaurants. And like if you say that movie is infantile, it is probably a negative thing. But then if you're talking about infantile cart, it's just the product itself. So it's very similar with rumors. So when rumor is talking about unrest in Ferguson and it uses some sort of language, and then it's going to be using completely different language in completely different ways when they start talking about different things, about different countries and different events. So that's another challenging aspect of it.
Okay. And so moving on from challenges, sort of what kind of advances can we expect from your work and your research, and what are you most excited about?
So actually there is a lot to do in this domain.
Yeah.
So very common approaches that people have been taking so far is to collect lots of tweets, annotate them, and then just try to classify it using the single tweet, which doesn't take into account a lot of the information around the tweet, around the world. So one of the things we really want to do is to incorporate external information as well, not just the text of the tweets. Tweets often link to news articles and so on. Another line of work is we also want to take the time component into account, because rumors unfold and it's crucial to try to verify them as soon as possible.
Okay, cool. And so how long have you been working in AI for?
So I was doing a machine learning related project on classifying disease using human gut metagenomic data in my master's.
Okay.
And then now I'm doing PhD in natural language processing for 2 years already.
Okay, well it's still quite a male-dominated industry, and although like more and more women are coming into the industry, do you find that there are many challenges of being a woman in AI? And if so, what sort of challenges are these?
I'm not sure like to call those challenges. So there's certainly an imbalance, and there's certainly, I guess, the differences in the ways that men and women do like networking, how they collaborate. So it seems that well, maybe it's due just to, it's natural that sometimes maybe for women it's easier to start chatting with women, and for men it's more comfortable just to start chatting with men. Also, maybe, I don't know, women are trying to go for like establishing more deeper relationship, whereas men are trying to just have lots of, you know, a wide range of networking relationship that maybe are not as deep but might lead to something.
Yeah.
So I guess there are differences in how we are approaching research, approaching networking. In terms of challenging, I haven't faced any discrimination so far.
Well, that's definitely a good thing.
Yes, I think in general inclusion and diversity are important because it's not just the gender thing, it's also maybe about people of different nationalities,
yeah,
and
sure.
all sorts of inclusion, and it's important for you to feel comfortable and welcome in the field. And I certainly think yeah, we're moving in the right direction.
Brilliant. Well, that's definitely good to hear. So thank you so much for taking the time to join me today. I've definitely learnt a lot, and I'll be looking forward to hearing about your latest progressions in the future.
Thank you.
Check back in next time to hear from Ira from Facebook and the Allen School of Computer Science. Back in the summer, there was a video circulating where Barack Obama was lip-syncing, discussing his family, politics, and a bunch of other topics. This was actually a project that Ira worked on, and I'm really looking forward to hearing about the real-world application of lip-syncing and the problems it solves, as well as hearing about the AI algorithms that Ira helped to create.